I'm here with some folks from our data and AI team for retail and consumer. Harsha Konduri, who is one of our leads for that business, as well as Suresh and Giorgio, who are cloud solution architects. And we're going to be walking through our Demand Forecasting Solution Accelerator today. And with that, I'll just go ahead and hand it over to you, Harsha. Take it away.
Thanks, Matt. I appreciate the opportunity here. So as we kind of spun up the retail industry vertical within Microsoft and really defining what our industry verticals mean from a cloud standpoint across modern work, across infrastructure, across data and AI, and across business applications, what we've realized is there's a huge opportunity for us to help customers accelerate their digital journey from being able to transform their organizations with data. One of the areas that we found that there's a unique opportunity for us to be able to add value is to develop industry solution accelerators that take a customer from where they are with their data to almost a fully built production level solution within 6 to 8 weeks. Once we identified that this is an area that our customers really need our help in being able to transform, we've then kind of worked with a lot of retailers and CPG organizations to understand fundamentally what are the different kinds of problems that they were trying to deal with. And one of the most important problems that we've seen customers really tackle, especially during COVID and post-COVID, as they kind of organizationally have gone through the reset process, is really focusing on demand, in both for retailers that are making sure there's availability within the store, and for CPG companies that are making sure there's availability of their product within different channels that the retailers have to be able to sell. We found that demand forecasting is an area that retailers and CPG companies both really needed our help in modernizing their approaches. Now, fundamentally, there are like several layers of complexities with demand forecasting. Historically, what we've seen retailers really go through is organizational silos of actually building and forecasting demand. One thing we've done with our approach to demand forecasting, which Suresh and team will kind of talk you through that, is really take what has historically been a very siloed process and integrate it across the supply chain functions, the marketing functions, and the finance functions, unify data across those three functions to be able to drive an integrated demand forecasting process. Now, historically, again, like I said, retailers have been and CPG companies have been very siloed in how they approach demand forecasting. The other big challenge was lack of infrastructure to be able to build models at the depth that is needed. If anything, that retailers have realized during the pandemic, especially with off-the-shelf software and not having the ability to do custom analytics organizationally, either because of the capability, the infrastructure, or not having the skills within the organization. One thing retailers have realized that needs to change, and they need to be able to provide hyper-localized demand for specific SKUs, at specific stores, and make sure demand forecasts exist at that lowest level. The challenge to be able to do that has been, if you take up a SKU across 1,000+ stores and the kinds of combinations that exist, you're talking about having to, build many millions of models and then reforecast each time you get new information and new data. So what we've really done is we've taken a lot of the complexity away from our retailers and CPG organizations and have come up with a mini models approach that the team will kind of talk you through. But what it essentially does is it helps you build extremely sophisticated machine learning algorithms at a SKU store combination level if needed, and be able to do it at that depth for you to be able to get the most accurate demand model and demand signal and basically aggregate it across the chain and make sure you're ensuring that level of high availability and high level of customer satisfaction from having the right place having the right product at the right place within every store across the chain. The solution accelerators as such are meant to be a 6 to 8 week process where our CSAs and our specialists who have the industry depth and the data depth to come to a retailer, kind of help them build these models, and then really eventually empower them to be able to customize it for their own needs in a self-sustaining manner, so they can continue upon and build upon the work that our team does. And then, as the whole, as the years progress, and Microsoft continues to be an expert that they can tap on when macroeconomic factors or something about their own business fundamentally changes, and to be able to then rely on and continue to rely on their own internal expertise to enhance these models and continue to develop that IP. I'm particularly excited about the Demand Forecasting Solution Accelerator, and I'll turn it over to Suresh and Georgia to kind of walk you through the models. Thank you.
Thank you, Harsha. So I'm going to bring up my slide. So just go ahead and share my desktop. Let me know if you can start seeing my screen. Yeah.
Yep.
All right. Thanks. Yeah, so this is many models accelerator, as explained by Harsha. The question of why, I think he touched upon it. Also, I wanted to add to that is the real world problems are really complex. And to address those kind of problems, we really need many models, right? So size fits all is not going to work, especially when the complexity of the real world. So I think there is a strong need for many model solution, as well as, we live in that day and age. The stores are, all over the world, multinational companies across different geography and serving different demography as well. So how do we take this AI intelligence and serving to their specific needs, like, tailoring to their needs is paramount importance, right? So that is another thing as well. Of course, when it comes to accuracy, many models is the right way to do as well. So we are actually looking at a case study. We actually have taken an orange juice brand called Dominic. It is a fictitious company, and then we wanted to do this forecasting for each and every store they want, right? So the methodology they are using today, Excel to manually which is highly unscalable, non-scalable solution, because they have we're talking within a short amount of time, predicting for a few weeks what is that demand is going to be is next impossible. They do it in an Excel spreadsheet and manually. So we have also created some simulated data, and this is from the Chicago area grocery store. So personally, I've helped a lot of enterprise customers gone through their business cases, scenarios. One other example, currently I work for a retail organization within Microsoft. Couple of notable application is workforce optimization, and then also for thousands of stores, where the workforce is employed across. Also, you can look at to use it for campaign promotion, propensity models, and price optimization is one of the big hit for hundreds of thousands of products they sell, right? And also restaurant chains, building the demand forecasting across thousands of restaurants is another important thing that I've done personally for the customer that I support. It can be used for forecasting models at each division level. And utility company that I've supported in the past, we are talking about smart meters, wind turbines, and thousands of oil wells. So those are the places as well that I find this application. So we are actually going to look at two ways to make this happen, especially from the training perspective. One route is going through the custom script, and then the other route is using the automated machine learning. So I'll be doing the automated machine learning, and my colleague Giorgio will be walking us through the training using a custom script. But if you look at the first two steps are the same for both those training models. And the architecture we are looking at is, we have these orange juice stores, Dominic stores, across different geography, and they are serving up the data. What we are doing is, there is a pre-processing involved, because to make sense of the data or to run it through the machine learning, you need to be formatted in certain way, and then we take it in terms of the different stores, and for each stores we are coming up with a model, training that model and evaluating the model. Eventually we have this collection of models that we have with different versions, and different accuracy as well, and we're going to pick the primary metric that the customer is looking for, whichever makes sense to them. And then we're going to have, once we have this, we're going to publish it and have it available to, in the production for doing the inferencing. So we have inferencing pipeline. And then, it is going to give us for these particular parameters for these next couple of weeks, what is that demand is going to be, right? So that results, we're going to upload it, in a Power BI. And then we're gonna show how it looks like, kind of a fancy stuff. The key concepts we're gonna touch upon are the workspace. When we talk about Azure Machine Learning, which is kind of like a project, you need different components for the machine learning, for the metrics. All those components are available through the workspace. Also, it is a place where you can apply the governance and security as well. Dataset, something that we're going to bring it into the Azure Machine Learning, but you can also do the training locally on your machine as well. So this is open source. The Azure Machine Learning is built on the Python SDK. So that is a flexibility available right there. You can use the compute on your local, or if you need to train, like, when we talk about thousands of models, then we can actually look at, leveraging, tapping into the compute available in Azure Machine Learning. Then we're going to look at some of the Python script steps as we go through the code. And we also have the ability to run these parallelly through this parallel run step. And whole thing is orchestrated through pipelines. And the concept of automated machine learning, you bring in the data, it goes through different algorithms and provides you the best algorithm for the metrics or the constraint that you define, that you can choose, whenever you don't have the data science resources, which a lot of enterprise companies have. And you can, we also have Azure Open Data Sets, so that you can also leverage to train some of the models, and then you can take it and specifically apply to your own data set as well. So let's start with the demo. So I'm going to go into the Azure portal. So I get in there with portal.azure.com, so that actually logs me in, and it has the security that you need. You can actually go into the device authentication, things like that, through your phone and things like that. So this is basically the workspace that I was talking about. So if you look at the workspace, so you have you can actually have private endpoints, identity, you can create alerts and things like that. And the whole thing is encapsulated through the resource group. So it creates a storage account. So once you create the Azure Machine Learning workspace, these are the components that's going to come across in your resource group, right? So resource group is like a container for holding multiple resources together. So one of them over here is a storage account. If you recollect the concept of the data set is going to be stored over here. Key Vault is to provide the authentication for the connection strings. So you may be connecting to SQL data source and things like that. You want to capture those connection strings in a secured manner that you can do. And then this is the machine learning workspace, and this is the application insights to get metrics out of your machine learning models. And this is the container registry where you're going to register models, versions of models, and manage them. So those are all the different things. And then, of course, we can go into the machine learning workspace. So I'm going to launch the studio, or I can go here, click the studio web URL to take me there as well. So once I have this, there are several things you can see, authoring and the assets and the manage. So you can do, 3 different ways of authoring your machine learning. And these are the assets that you have: data sets, experiments, modules, models, and endpoints. And these are the manage. You can manage the compute, environment, data stores, data labeling, linked services. So I'm going to go into the notebooks here. I've already imported the models. So let me take you to the GitHub page where I got this whole information. If you're wondering, I didn't, create this code from scratch, but this is the many models solution accelerator that is available in GitHub. That I leveraged, and it has very good, content that you can go through. So these are all the prerequisites, and then you can actually get started directly by clicking this deploy button. And of course, the prerequisite is you need to have the Azure subscription, and once you have that, you can actually click this deploy to Azure, and it deploys it for you, right? And then you can also configure different environment, or you can actually go ahead and set up the compute for example. So in this case, it walks you through how you can actually specify the machine sizes, and we have the option of CPU and GPU depending on your needs. And you can clone the Git repository, which is what I did, into my machine learning workspace. So I already have, and then you can actually do this on your, Jupyter Lab from the Azure ML itself. So Azure has this notebook service that is available. Exactly the command that I leveraged is how I got that many models into my workspace is using this command. So once I have that, and I come into here, and this is where I will see those many models. And then I can click on setting the workspace. So these are all the information that I need to provide about my subscription ID, my resource group, the workspace, and which region my workspace is created. Also, what I did was I went ahead and clicked on the file, clicked on the edit in Jupyter, and that popped up this notebook for me. So if you are liking this experience of using the Jupyter notebook, this is where you will end up by clicking that. So like I mentioned, so you provide these specific information, which is what you need to do, but rest of the codes are coming from the GitHub repo in the notebook itself. So with this ones, we're going to, if you have not created the workspace, so this is where it will create it for you if it doesn't exist already. And then once the workspace, Azure Machine Learning workspace is created, you can get the workspace details to see if it's successfully created or not. Like, what is the workspace name? What is the, the subscription ID and things like that. And we want to write it into a configuration files that actually appears over here. So executing that command will actually make it right into the workspace right here. So that is what is done by this workspace.writeConfig. And then you can specify the compute cluster name. So CPU cluster is in our case. So you can create using the recommended compute cluster, standard D13 V2. And once you have that, so if you have not created the compute already, it will go ahead and create it for you. But if it is already created in my case, so it says found an existing cluster, so I'm going to use it instead of creating a new one. Then I come into the next steps. I click on the data prep. So in this case, I wanted to make sure a few different things, downloading the sample data into my data set, and then splitting the data for training and forecasting sets, and then connecting my workspace and uploading it to the data store. So these are all the things. And of course, the prerequisite is what we have done in the previous notebook. And then I download the sample data. The open data sets that I was talking about is precisely what we are leveraging here. So I use a pip command installing this open data set. And once I have the open data set, so here is where I'm specifying, hey, do I want to do it for all the 12,000 stores? Or maybe start with 10 stores and see how this works. And then I can, think about leveraging it for, about 12,000 stores. Okay. So I recommend maybe you start with similar like I did, like, start with 10. And then depending on how it goes, then you can expand it to the needs that you have. Maybe it's 12,000 or 20,000, whatever the case may be. So I'm importing from the open data set orange juice cells simulated data in this case. So I'm getting that file data set into the variable files, OJ sales files. And then I pull only the first, the 10 files, dataset max files that I already defined. And this is the target path. And then I download those files. As you can see, store 1,000. In this case is Dominic's. In this case, Minute Maid. In this case, Tropicana. So all those, in my case, 10 of them I download. And then I split into two sets. And I'm giving that logic. Anything before this date is my training data set. And then the rest of them is for my forecasting. So that is what is being defined through the split data over here. Then I upload the data into the Azure Machine Learning workspace. So I'm getting that configuration. You remember we returned this configuration file, so that I can get it through this. So I get those details, and then I'm going to upload it over here. So from the data store, and then upload it to the training path, and this does these actual upload for the training data. Same way I'm doing it for inferencing data as well. So once I do that, this is for the train data I can see, and this is for the inference data. And these are all optional, so you can even create the data store. So this code walks you through that. And once I have that, train data, I can train model. I can, once I imported that data set, I can register the data set using the code right here. So I'm just taking only the small, which contain only the 10 records or 10 stores that I'm registering there. Excuse me. This is to interact with the registered data set. And then it is just to see what is the path of the data download. And you can see some more details on the data per se for about 10 records or so. Now that we have trained the data, now we can actually take it into the automated machine learning. So going to no, we just prepared the data, right? So we prepared the data. Now, one of the two ways that we were talking about is using the automated machine learning. The other is a custom script. So I'm going to walk you through the automated machine learning. So this is the, I'm going to use the pipelines. So I'm installing that pipeline using this command. As you can see, it goes through different libraries and then get me that pipeline steps. Here I'm setting up the workspace, data store, and the experiment. So similar way what we have done from the previous notebooks. I'm getting the details of the data store, just printing to make sure this is the right workspace, resource group, and the dataset name. And then I'm, creating an experiment. So I'm saying, give me the experiment with this name. So this experiment, is going to be used for the training. So I'm calling the registered data set. I'm going to use it for the 10 models, like I mentioned. You can do it, for all the 12,000 that we talked about, but I'm using for only the 10 stores. And here is I'm using the compute. So for running the notebook, you also need a compute that we have already created. But for training, depending on how many nodes that you want, how big is your data, you can choose that compute that you need. In this case, we are recommending standard D13 V2. You can specify the minimum nodes and maximum nodes here. And once we have it, I already have this compute created, so it formed the existing compute, and it is going to use that compute. So these are all the the primary metric that I'm going to leverage. What is that may be different for you. So one thing with this, the task is forecasting. So automated machine learning can also be used for regression as well, and classification on top of the forecasting. So for 3 different kinds of scenarios that you can leverage. So I'm going through the logging, so you can actually create the partitions that you need to specify the store brand. And these are all the automated machine learning. So remember the constraint that I talked about. So you need to specify those constraints. So what is the primary metric for you? For me here is normalized root mean square. So this is how you control, and what is this number of iterations that you need. You can specify that. So those are the knobs and whistles for you, right? So you can control that. So it is in your hand. And then we're coming and building the mini models here based on the settings that we provided. So this is again the pipeline steps we're going to use. So this is the pipeline builder with the automated settings and the data set for the 10 models and the compute that I specified, and what are the partition column names as well. So I'm going to run the pipeline. So these are the run details. So having defined the training step and the workspace, I'm submitting it, and then I can click on this to get the run details once the training is completed. So you can actually kind of see, and these are all the log that you can go and take a look. These are all the steps that you can click to see what are all the steps it went through. So this is, we are running it for 10 models, right? So it started, the parent one was 6, and then, from 7 to 16. So 10 of them have been completed here. And you can see, what is the best score right here for you. And then based on the primary metric you define, you can download the best model and then you can use it. And these are like the logs that I talked about to see if everything went fine, or in the process of debugging, that also you can actually do that from here. So yeah, this is graphically represented. So going back to the automated here. So yeah, once your training is completed, you can review that, make sure everything went fine. And then, you can review the output of the training model, and then get the list of the automated machine learning with the registered model names and tags. Because you can automatically kind of register the best model for your primary metric, and then we can automate the whole thing, right? So we are talking about like the DevOps or MLOps, or you want to retrain your model, because one thing for certain is the machine learning model has a shelf life, right? So it's going to get outdated at some point in time. So you need to do the retrain. So that's why you can actually publish into your pipeline, and you can do the schedule retrain with a frequency of every month, or depending on whatever the case may be for you, right? Or you can cancel any runs that are running anytime. So that is what I wanted to walk you through with this one. And the next one, I wanted to have Giorgio come and talk about the custom scripting. So Giorgio, when you're ready, you can take it over from here.
Absolutely. Let me go ahead and share my screen. All right. Now, Suresh already shared with us the main steps, right? After that, you can either do automated machine learning, or if you feel more comfortable with data science skills, you can dip into custom scripts. Now, I usually use automated ML a lot, especially to use it as a baseline. And in that point, I can then use my own algorithms to then try to beat the AutoML. But that way, I don't have to spend a lot of time thinking whenever I have a problem out of the gate. Now, on the custom script path, again, it's the same approach, it's the same data set, same issue. But instead of going to the automated ML, we go from the data preparation into this pipeline. And we can even see it on the actual files, where it is even separated by folders, and you can navigate through them. The first step in whenever you want to do anything is to connect to the workspace. Now, that workspace is already configured from the previous steps that Suresh did, or you can even connect if you have access to it, and you can even specify either the workspace name and any of those. Then you create an experiment. In our case, we're going to be calling it OJ Training Pipeline, which again, it can be either for custom or automated machine learning. These are just two different processes that are doing the same thing. From here, we're going to then get access to the same dataset that Suresh was using, which is OJ data small train, and then we are basically going to import it from the datasets already in the workspace. Now we basically create and configure the environment, which is making sure that we have the actual libraries that we need for our training. And that way, everything will be basically a standard across any runs. We select the same compute cluster, and in this case, we don't even care to create it because we already did it on the previous steps. And now we basically do something very similar to Suresh did on the automated ML, where we create an actual parallel run config from where we can define multiple things. For one, we can specify the actual environment. And from the environment, basically, we can have multiple different configurations depending on the actual experiment that we want to run. And you can even select or even create your own environment in here. You can specify the actual script that is going to be the training. Now, in this case, the training.py is one of the main components in Azure Machine Learning because it allows you to basically configure any type of algorithm or use any type of machine learning library that you may want to use. Now, in here, I have the actual train.py, and I can even go and edit it directly into VS Code, which is basically right here. And as you can see, either if you do it on the portal or if you do it locally in your machine, it's the same thing because I'm connecting to the actual machine learning workspace. It's just a matter of preference. Now, for example, in this case, this train.py, it has two very important functions, init and run. Now, the idea from init is basically get to run the actual, to set up everything, the actual run from where you even are getting the parameters from the pipeline, and then just basically initializing the whole thing. Then the run function will basically be executed every single time that basically the actual training function is executed, or even whenever every single training row is executed. You define the training time, the start date time, the file name, the model name, and all of these are basically parsed from the pipeline in order to be able to do that. In this case, it's a very simple forecaster that we're using. It's using also some additional functions that we have available in here. Now, things like column dropper, you can have your own specific library that you want to use in order to actually do the work. This is actually the scikit-learn wrapper in order to be able to feed and to train the model, where you define the column name. And again, this is super simple. It's the scikit-learn wrapper, but you can have in here models from either H2O, you can have TensorFlow, you can have any type of model, because at the end of the day, this is Python. And that's one of the beauty of it. Now, once you define that, you basically are able to get the predictions on the test set, compute certain metrics, and then start logging all of those metrics in order to be able to know when to stop the training, or basically to have it for posterity. Now, from here, you register your model once you are comfortable with it, and then you can even save the result files for the future, basically. Now, if we continue in here, again, pretty similar to the previous step, you specify how the experiment is going to be behaving, what is the actual configuration of the running, and you can basically specify where it's going to be saving those results. Now from here, this is basically part of the same pipeline where you are defining, use the configuration that we defined before, use this input dataset, save it in this directory, and these are the main arguments that we are going to be using. Even these are the arguments that we saw before in the other Python train.py file. And from there, basically, you just run a submit the experiment. This is going to be running either on the cloud or in your local machine if you decide to do. And you have the flexibility and the option to do it. On top of that, you can basically here just wait for completion. It will take some time, especially depending on how many models you're training. But a great thing is that depending on the amount of models and also the type of compute, it will behave pretty much the same because it's not training. It's not a linear time that you have to wait, because basically you are dividing the store product combination per node and basically in every single job while you are training. And then from there, you can basically get access to the parallel run step text file, which is basically you can get it from the workspace and see, okay, everything is working fine. You can even get the actual data that it was trained on and even review the actual results. And you can see, okay, I trained 10 models. These are my average metrics. This was the duration of the training for each of them. And this is just some ways of visualizing, okay, what are my metrics by brand of the orange juice in this case. After you are comfortable with it, you can say, okay, fine. I can then schedule the pipeline to be run every week, every day, or even, which is a little bit more advanced, you can define some data drift monitoring, which will allow you to know when to retrain the model and not just a specific time. And this is for training, and this is great. But then how do I actually use my model? Now that I have a model, we go to this other file or pipeline, which is a forecasting pipeline. And again, same process as before. We connect to the workspace. We define, we have an additional experiment, right? Forecasting pipeline, which is going to be governing the whole thing. Imagine the experiment as basically folders that you define everything. And whenever you have a new project, you can have one or more experiments and have every single run for that experiment in the same place. Now from here, we are basically have another data set, which is for inference specifically. We load the data set and we create another step for our pipeline. In this case, again, remember, these were the actual packages that we use for training. We need to make sure that we're using the same one, because if not, you're not going to be able to use your model. And you can even specify, of course, the actual version if you need to. Now we use the same compute cluster for the inferencing as the training. Is not uncommon to have different compute targets depending on the use case or even different projects just to manage the latencies. And you can in here basically configure the same pipeline, but the main difference, you can see that it's right here. It's a forecast.py. And again, what does it do? You can go and see what is actually the Python file that is being executed. Again, you parse your input documents, and as you can see, it has the init and the run. Pretty important to have those two functions. And then from here, you get the input data, you go through it, you load your model, and you're able to basically score, get your predictions, and then send back your predictions, which allows you to have way lower latency as if you were going to do it one by one. Now, with that parallel run, you can, again, submit it, create a data reference to be able to get the actual predictions. And then from here, you have the actual Python scripts that will be copying those predictions for us to configure. As you saw, the training, we just care about the training and that's it. But in this case, we have another step that we can even see, okay, what is doing copy predictions? Well, you can basically make it to do anything that you want. In this case, you are getting the results from the actual parallel run text, and you are then copying them and outputting and basically making a CSV. Instead of making it a CSV, you can then, I don't know, upload it to a database or push it to your data lake or data warehouse or anything like that. Now from here, again, you run the pipeline, you wait for completion, and basically, again, you can even have this pipeline be run daily, weekly, hourly, whatever is the time that you want it to do. And from there, you can get the actual predictions for the demand that it was forecast for, in this case, 10 models. But again, the whole framework basically is the same if you have one model or 10,000. We can, in here, we can just see the predictions, pretty seaborn visualizations, and even the actual predictions by brand. As we can see here, Dominic's is the best selling in this case for these stores. And of course, this is specifically to the store. But again, we already have the data. Whatever we do with the data is up to us. Basically here, you can see that I have 2 pipelines scheduled, and I can even go directly to my pipelines right here. These are my 2 pipelines. And even as we saw before, we have all the information from those pipelines. We have the many model forecasting. We have, and this is super important, we have even the files. Now, you have both the data that you use, right? But you also have the actual files, the actual scripts that were used to train something. That way, in 1 or 2 years from now, you don't have to start guessing which version you used to be training or even what data or anything like that. Everything is in here, which makes everything easier. With that, I believe that I have covered at least the custom script part, where you can have the data set, you have more control of basically the algorithms that you use in case that you want a little bit more control instead of using directly AutoML. And with that, I can give it back to you, Suresh.
Okay, sounds good. Thank you, George. I appreciate that. Walking through that, really nice. So I'm going to share my screen for wrapping up with the summary. All right. So yeah, what we have seen is, we went through the case study. We went through why.
Hey, Suresh, could you share your screen one more time?
Okay. Let me go ahead and do that. Give me a moment. Right. Is it coming up okay?
There we go. Perfect. Thank you.
Thank you. Thank you for indicating that. I appreciate that, Matt. So yeah, so in summary, we went through why many model solution makes sense. And we went through the case study. What are the industry business use cases? This is more applicable. 2 different ways to achieve the same goal. We touched on the architecture what are the different components, what are the key concepts as well, right? And then walk you through the training. Forecasting is same as what Giorgio did, so I didn't cover that in my part. So so you can listen to Giorgio to understand the forecasting. So it is similar to what you do with custom script, the same for automated ML. And then Giorgio walked us through the custom script. Right, so you can automate that in different way. But I also wanted to give some more information. Basically, we think things will all work and go smooth. It may not be the case. So for such kind of things, we have created troubleshooting guide at a high level. So you can actually go through if you come across any issues, and we also have documented some known issues. Make sure that before you spending cycle, take a look at this, help yourself. So that you can do. The other thing is, so when we actually look at these thousands of model or 10,000s of model, we taken the result and we actually, thanks to Erica, actually created this Power BI dashboard. So you can see like for different items, different departments, different locations, right, and different stores, right? So when I click on, say, store, so give me a moment. There's a lag. So basically, yeah, you can actually come up with, yeah, there you go. Now it's changing. Okay, so I have to refresh it. So you may have a different parameters, different stores. So you can actually come up with a dashboard like this, do the demand forecasting. So you can see for the store 1003. Sorry, it's taking some little bit of time to refresh it, but that's the bottom line, right? So that's what we are seeing. So this is still loading. You can see for Arizona, and for the by month, when we do this prediction, what is the actual versus what is the predicted. So using this model for the sample data, at least it was kind of more accurate. So similar way, you can train to your data and come up with the accuracy that you want. But this is a nicer way, I thought, to kind of show it to you. So what can be done to make something with the visualization, right? Yeah, so the next steps I would recommend is, you can actually download or get into your Azure Machine Learning subscription, download this accelerator. Also, if you are an enterprise company, you have a account team from Microsoft, you reach out to them as well, so they can help you to implement it. So a lot of the customers who even don't have the data science team, they can also leverage this to come up with a base model, and then they can improve upon it. So I have seen that also happening. Plus, in addition to what you're going to see, you can also look at the videos over here. So they have some more details as well, and the concepts with what we went through, parallel run step pipelines and automated machine learning. So that's all I actually wanted to discuss with you, demo to you. But I wanted to turn it over to Matt. Thank you, everyone.
Thank you so much, Suresh, Giorgio. Great stuff. And yes, if you've got questions, feel free to reach out to us at msusdev@microsoft.com. And we will see you next time. Thank you.
Thank you.